For this question, we're going to be using integration by parts. So it's a bit tricky because we don't have just two terms. We have three terms multiplied by one another. We have the 2x squared, the sec squared x, and the tan x. So then it's a bit tricky to realize what exactly we set our u to be, what we set our v dash to be. Let's start with the late rule. Logs, algebra, trig, exponentials. We have algebra, trig, trig. So a comes before t in the word late. So then we can set our u to be equal to 2x squared and our v dash equal to both trig things multiplied by one another. So sec squared x, tan x. That's useful because we can integrate this whole thing. We can integrate sec squared x, tan x. Let's do that on the right hand side. The integral of sec squared x, tan x. So we can use reverse chain rule for this. We can use substitution. If we were to set u to be equal to tan x, because the differential of tan x with respect to x is sec squared x, that means that when we sub in or replace the dx, we'll be dividing by this, and that will cancel out this sec squared x. So let's do that. This becomes the integral of sec squared x, the tan x becomes u, and the dx becomes, I'm just rearranging this actually, dx is equal to 1 over sec squared x du. So times by 1 over sec squared x du. These two cancel, and then we're left with the integral of u du, which is just u squared over 2 plus c, and that's the same thing as, because u is tan x, tan squared x over 2 plus c. So v is equal to a half tan squared x. And then u dash is just 4x. Alright, so now we can put this into the integration by parts formula. So it would be u times v. So the 2 multiplied by the half would just give 1. And the u times v would just be then x squared tan squared x minus the integral of vu dash. So we have a half and we have 4. Those two things times together to give 2, so this becomes 2x tan squared x dx, and we can use integration by parts again to integrate what we have here. We can set, using the late rule again, we have 2x being algebra, tan squared x being trig. So u is equal to 2x, v dash is equal to tan squared x, and we can't integrate tan squared x as it is. We have to use an identity. We have to use the identity that tan squared x plus 1 is sec squared x. So then tan squared x is equal to sec squared x minus 1. So let's rewrite the v dash as sec squared x minus 1. We can now integrate that. Sec squared x just integrates to make tan x, and the minus 1 integrates to make minus x. Differentiate this, that gives 2. Okay, so let's just call this bit here, let's call this thing here b. So b is then equal to, so u times v, 2x times, I'll expand this out right now, 2x times what we have here. So it'll be 2x tan x minus 2x squared. So that's u times v minus vu dash, or the integral of vu dash, the integral of this times 2. So 2 tan x minus 2x. Okay, so this is then 2x tan x minus 2x squared. So tan x integrates to make ln sec x. So minus 2 tan x will integrate to make minus 2 ln sec x. That is in the formula booklet. The integral of tan x is ln sec x. And then we have the minus 2x that integrates to make minus x squared. And the minus here makes it plus. So it'll be plus x squared. And now we can put it all together. So our answer would then be, so looking back up to what we had here, so this is what we had originally, and then we just worked out what b is. So This then becomes x squared tan squared x minus all of this. So I'll evaluate the minus sign now. So it'd be minus 2x tan x. And maybe I'll combine these two together as well now. So those two would make minus x squared. But then we're subtracting this whole thing. So the minus x squared now becomes plus x squared. So plus x squared. And then we have minus 2 ln sec x, which becomes plus 2 ln sec x. And finally, plus c.